it's very important to understand the relationships of the graphs between your original, your derivative, and your second derivative. And so we're going to be sketching them by hand, reading the original, and graphing the graphs of the derivatives, which we can't see, but we're going to read that information off of the original graph. And so it's important to be able to do it by hand. It's also important to be able to just look and know. So I want to encourage you to be putting your derivatives in your calculator with your original and look at them in different colors so that you get real familiar and this becomes very easy for you. Okay, so getting started, we're just going to copy the original over. It has a vertex at 1, -1, an x-intercept at 0, an x-intercept at 2. And we'll label it f of x. Okay, now we need to think of the relationship between f and f prime. F prime is the slope of f of x. So reading the slope from left to right, we can see that f prime is a negative slope until it hits x equals 1. And at this point, notice how that's a horizontal tangent. F prime of x, remember it equals 0 at all your critical numbers, and a minimum is a critical event. And then after it passes that minimum, f prime changes its slope and becomes positive. So we know it has to cross at 1, that it's 0, that the f prime of 1 is 0. So I can plot that on my graph. And then I know that the graph is steep at the top of the parabola, but as it approaches to the vertex, that tangent line starts to flatten out. And so at -1, steep negatives, and then I have to approach that value of 0 at 1, and then I become positive slopes. And so my f prime of x is a line. Now, f double prime of x. What's the relationship between f double prime of x and f of x? F double prime of x is the concavity, the curvature of f of x. And we can see that this parabola is concave up everywhere. Okay, so that means that f double prime of x is positive. Okay, now another relationship that we have is between f double prime and f prime. So remember, every time you derive, the derivative that you've just derived is the slope of the function it came from. So if I derive f prime and I get f double prime, then that means that f double prime is the slope of f prime. Because f prime is the slope of f. Every derivative is the slope of the function it's derived from. Okay, so I'm looking at f prime. Well, f prime is a line, so that slope is constant. So that means f double prime is going to be a horizontal line. Because it's concave up, it's positive, so it's going to be above the x-axis. So if I roughly gauge it from my sketch so that my sketch is all consistent, this is a slope of up 3 and over 1. So at 3, I have a horizontal line, and that's F double prime.